Naming a simple ionic compound. The question says, provide the name for each of the ionic compounds below. So here we're going to try to name Na2O, which is that white powder in the bottom right. So here, the first thing you want to check is whether you have an ionic compound at all. An ionic compound is a metal plus a nonmetal. And metals are everything to the left of that staircase. That's on the right side of the periodic table. And nonmetals are everything to the right of that. So sodium, Na, is a metal because it's to the left of that staircase. And oxygen, O, is a nonmetal because it's to the right. So because we have a metal and a nonmetal, it's ionic, and it will have the naming conventions that we're about to use right now. So for naming an ionic compound, take the name of the first element, so here Na, exactly as it is on the periodic table, so sodium. Then, for the second element, here it's O on the right side of the periodic table, take just the first syllable. So the first syllable of oxygen is ox, take just ox. And finally, add the ending IDE. That ending means this is in a compound. This oxygen is sticking to the sodium. So the name of the full compound is sodium oxide. So when you take sodium, react it with oxygen, you get sodium oxide. And sodium oxide helps glass melt at a lower temperature. So when you're making glass, you take mostly sand and then you try to melt it down. And then when it cools back down, the melted sand will be glass. But just pure sand melts at around 3,000 degrees Fahrenheit. Whereas if you add the sodium oxide, it'll melt at around 2,500. So it melts at around 500 degrees of a lower temperature. And that's liquid glass. Alright, how do we name MgBr2? So first, let's just make sure it's an ionic compound. We have a metal, because it's to the left of the staircase, a nonmetal, because it's to the right. So we have a metal and a nonmetal, that's an ionic compound. So for ionic compounds, take the name of the first element, exactly as it is on the periodic table. So here that's magnesium. And then for the second element, Br, take just the first syllable and add the ending ide, IDE. That shows that it's in a compound. The bromine is sticking to the magnesium. So the name for MgBr2 is magnesium bromide. If you take magnesium and you react it with bromine, you get magnesium bromide. And magnesium bromide is used as a mild sedative and an anticonvulsant for the treatment of nervous disorders. How about Ca3P2, the white powder in the bottom right there? What's the name for that? So first, let's make sure we have an ionic compound. We have a metal, because it's to the left of the staircase, a nonmetal, because it's to the right. And so metal and a nonmetal, that's an ionic compound. To name an ionic compound, take the first element, give it the name that exactly as it is on the periodic table. So Ca is calcium. Then for the second element, take just the first syllable, so here that's phosph, and add the ending ide, IDE, to show that it's in a compound. So Ca3P2 is called calcium phosphide. So if you take calcium and you react it with phosphorus, phosphorus is the red stuff at the end of a match, then you'll get calcium phosphide, which is mostly used to kill rodents. Supposedly, it can be made by boiling bones in urine, and once you have it, when it comes into contact with acids or with water, it makes a toxic flammable gas called phosphine. So what'll happen with rodents is they'll eat it. When it comes into contact with the acid and water in their stomach, that toxic phosphine gas will be made and the rodents will die. How about Al2O3? So let's make sure it's an ionic compound. We have a metal and a nonmetal, so it's definitely ionic. To name an ionic compound, take the first element, name it exactly as it is on the periodic table. So here, aluminum. For the second element, take just the first syllable. So here that would be ox from oxygen. And then to show that it's in a compound, add the ending ide, IDE. So Al2O3 is called aluminum oxide. So if you take aluminum, which makes up those aluminum cans that sodas are in, mix it with oxygen, then you will get aluminum oxide. Aluminum oxide is really hard, and so it's used on the surface of sandpaper to help smooth things down, and it's also added to paints to help make them glossy. This is one of the things that makes like new cars shine more. How about LiCl? What's that called? First, let's make sure it's ionic. So we have lithium to the left of the staircase, so it's a metal. Chlorine to the right of this staircase in bold, so it's a nonmetal. A metal and a nonmetal is an ionic compound. So to name ionic compounds, take the name of the first element. Here Li is lithium, so name that exactly as it is on the periodic table, so we have lithium. Then for the second element, take just the first syllable. So Cl is chlorine, the first syllable of that is just chlor, and then add the ending ide, IDE, to show that it's in a compound. The chlorine is sticking to the lithium. So LiCl is actually called lithium chloride. So if you take lithium and you mix it with chlorine, now here this chlorine is very, very cold. That's why it's a solid. At room temperature, chlorine is a light green-yellow toxic gas. And if you react lithium and chlorine, then you'll get lithium chloride. Lithium chloride is, among other things, used to color flames. It gives them a dark red color, and that's used to make fireworks. How about BeF2? What's the name for that? Alright, well let's make sure it's an ionic compound. You have a metal and a nonmetal, so it's definitely an ionic compound. Now to name ionic compounds, take the name of the first element, Be is beryllium, and name it exactly as it is on the periodic table, so beryllium. For the second element, take the name on the periodic table and take just the first syllable. So here, F is fluorine. The first syllable of that is fluor. And finally, add the ending ide, IDE, to show that the fluorine is sticking to the beryllium in a compound. So the name for BeF2 is beryllium fluoride. So if you take beryllium and you mix it with fluorine, again, this is very, very cold fluorine, that's why it's a liquid. At room temperature, it's a gas, and it's almost invisible, although it is a light yellow. If you take beryllium, react it with fluorine, you'll get beryllium fluoride. Beryllium fluoride is mostly used as a source of pure beryllium. And because beryllium is so rigid and stable and light, they tend to use it to make spacecraft and satellites. So here, those silver mirrors are mirrors that are going to be used in an outer space telescope. Thanks so much for your attention.